Hi guys, this is Mr. Urrego, and today we're learning how to expand logarithmic expressions. We have three problems here because we're going to expand using three different properties. My first property is the product rule, or the product property. It says that a product of my arguments, log on base 4 of 7x, which is their multiplying, is going to expand using the sum of my two logarithms, meaning the first one is always the same base, log on base 4 of my first one, plus the log on the same base of the second one. Using the quotient rule, a log of a quotient, what happens is, if I expand it, it's going to be the difference of the two logarithms. So my first one is going to be log on base 7 of x. The product is added, the quotient or division is minus, log on the same base of the denominator. If you're able to evaluate, you evaluate. Like if I had log base 7 of 7, then you are able to evaluate, which will be 1 at that point. But right now, nothing that I can do without doing the change of base, which we'll talk in a different video. The last one is the power rule. I have an exponent. When I have an exponent, what happens is that exponent is going to come multiplying in the beginning of my log function. Right now, ln, natural logs. Okay, questions about these properties, the description have videos. So when I have a power, an exponent, what happens is that exponent comes in the beginning and is going to multiply my log function. In this case, I have ln of x. So we have two more problems. ln of e to the third power over 7 and ln of square root of x. Okay, what do? My first thing is I have a division. So I was going to break into ln of the numerator minus ln of the denominator. What happens is, if I have an exponent here, then I have to use the power rule. And that 3 is going to come up to the beginning of my function, and it's going to be 3 ln of e. Minus, there's nothing that I can do with this, so it stays the same, ln of 7. Here, technically I have an exponent right there. The square root of x is the same as having, I'm just working on the square root of x. X has a 1 as an exponent and it has a 2 as the index. So if I rewrite this, I'll have x to the first power, and this 2 will come here and divide my 1. So square root of x is the same as x to the 1/2. And now because I have an exponent, that exponent comes in the beginning, and I'll have 1 over 2 ln of x. Now we have to expand this one. As you can see, we have more now. Okay, so now this is a product. Okay, I have 2. So the first thing is, I see that I have an exponent and I have a radical. That radical I have to put in an exponent. But then the first thing that I need to expand is my product. So having this is the same as having log on the same base of the first one plus log on the same base of the second one. Okay, having this, then I got to work on my exponents. So I have log on base b of x to the second. I haven't turned that because I want to do the square root of y, plus log on base b, and now square root of y is y to the 1/2. Once I have my exponents ready, I turn them in the beginning, and that's going to give me 2. Remember, this 2 comes in the beginning, log of base b of x, plus that 1/2 comes in the beginning of log on base b of y. Okay, always the same steps. First the product, then my exponents. Let's try another one. Now I have this, log on base 5 of cube root of x over 25. Division, first thing I do is I break that into a difference. So I have log on base 5 of the top, which is cube root of x, minus log same base of the bottom, which is 25. Now I got to work with my argument. All right, I have a radical here. That means I have to turn that radical into an exponent. Remember, I have a 1 here and 3 is dividing. So it's going to be the same as 1/3 minus log on base 5, but I have 25. But 25 is the same as 5 times 5, which is 5 squared. All right, so I turn 25 into 5 to the second power. Once I have that, I notice that I have exponents, so those exponents will come to the front of my function. So I have 1/3 log on base 5 of x, and I'm done with this problem, minus 2 log on base 5 of 5. Supposedly I'm done expanding, but then you have to see how much is log base 5 of 5. Okay, so I can solve this because log base 5 of 5 is equal to 1. Therefore, my final answer is 1/3 log base 5 of x minus, if this turns into 1, 2 times 1 is 2. And this will be my final answer. Now to finish, let's do this little monster like I called them. Okay, so again, it's the same idea. But now, if you notice, I have 1 on the numerator, but I have 2 terms on the denominator. What's going to happen is everything that is divided, it will expand as a subtraction, as a difference. Okay, so let me show you. So the first step is we're going to break the product. So what's going to happen here is I'll have log on base 6 of the top, which is cube root of x squared, okay, minus log on base 6 of 36 times y to the 4th power, because this is the denominator. But now I need to break that out, okay? So let's rewrite this. This is going to be log on base 6, and now my exponent is going to be x to the 2/3 minus. Now this is a product. Because this product is going to break into 2 terms, I need to put a parenthesis here to make sure that I understand that it's going to be 2 terms and that minus is going to affect all of them. So here I have log base 6 of 36 plus log base 6 of y to the 4th power. Okay? Keep in mind, this negative will affect the first one and the second one. All right, so let's play around with the negative only. So I have log on base 6 of x to the 2/3 minus the 36 is 6 times 6, which is 6 squared. Let's turn that into 6 squared. So negative and positive is going to give me negative log on base 6 of 6 to the 2nd power. That's my 36. Plus, oh, hold on, not plus. Negative and positive would be minus, and I have log on base 6 of y to the 4th power. My last step, let's bring those exponents in the beginning. So my last step is 2/3 log on base 6 of x. Here, the 2 will come in the beginning, but log base 6 of 6 turns into 1. So it's 2 times 1, which is going to give you 2. Minus, I'll bring the 4, and I have log on base 6 of y. So your last step, every time you're expanding, is to bring the exponents in the beginning of the log function. Okay guys, thank you for watching. Please subscribe to the channel, like the video, and next, condensing logarithmic expressions. Here? I don't know. I'll see you in the next one. Take care. Bye-bye.